Alright, so let's proceed for that for a dimeric protein. Now we'll try to increase my writing so you can see very well. Now for a dimeric protein, like I said, we're going to represent it with what? With M, right? So M2, M2, okay? So there's a protomer having two active sites, right? It is going to combine with what? It will combine with, first of all, one substrate, S. Are you getting my point? So that I can now say what? When you combine with S, we're going to get what? What are we going to get? We're going to get M2S. This is the first product we will get. M2S. Okay? Now, this M2S now, it is not yet saturated. M2S is not yet saturated. So I will take this M2S again and combine it with another substrate such that I will now write like this. M2S plus S will give me what? Will give me what? M2S2. Now with this now, I can say that the enzyme now is now fully saturated. I will come again with it. This is a dimeric protein. There's a protomer having two active sites, meaning it can combine with how many substrates? Two substrates, right? So it combines with the first substrate and it forms M2S. Then I said, oh, this thing is not yet saturated, it's not yet complete. So I take this one again, M2S, react with another substrate in that form what? M2S2, meaning that this case now it is not fully saturated. So I will label this first one as what? As reaction or binding constant 1, KB1. KB1. I will label it as what? KB1. While the second one, I will label it as what? KB2. So this second one now, we call it what? KB2. Please don't mind the camera. Label it as what? KB2. Okay? Now, if this one is clear now, let's now proceed. Let's make KB1 subject of the formula. Let's make KB1 subject of the formula such that KB1 will be equals to what? The product all over the reactants. These are the reactants. Okay? Product all over the reactants. What's my product there? M2S, right? All over. Where's my reactant? My reactant are what? M2 and what? And S. So put it here. So we have M2, then we also have what? S. Are you getting it now? Now the next thing you will now do is that you will make this M2S here, which is okay. Let me just introduce something now. It's very, very easy. Let me introduce something now. Please listen. This part of the equation, I know the camera is a bit blown now. This part of the equation is for the unbound, while this region is for the bound. Meaning, what do I mean? I mean, this part of the equation here is for what? Unbound protomer, while this region is for what? Bound protomer. You get my point? So I can say that if I'm to put, if I'm to label this place in a bracket, let me say I put this place in bracket, I will tag it as what? As unbound protomer. Meaning in this region is for the protomer that is not yet bounded. Now you'll be tempted to ask me a question that this one is bound. But yes, I know it's bound, but it can still combine with another substrate. So that's why I said both this M2 and M2S, as far as they are in this region, they are termed as what? Unbound. While this one is known as what? Is known as what? Is known as the bound protomer. So what am I trying to say? Once you take your KB1, KB1 is equals to what? The product M2S all over the what? All over the reactant M2 and what? And S. The next thing is that you will always make the bound protomer subject of the formula. So what is the bound protomer? Is it not this one? Yes. So the next thing I will make M2S subject of the formula. So making M2S subject of formula. Meaning we will now have what now? What are we going to do? We'll have things like what? M2S is equals to KB1, right? In bracket M2, then in bracket S. Do you get it? Do you get it? Alright, so I would term this one as what? As what? Equation 1. I'll come again with it. For a dimeric enzyme, the first thing is that we take what? We acknowledge the fact that the enzyme is having how many sites? How many sites? 2 binding sites, right? Meaning it can combine with the first substrate, and the rate constant will be what? The binding constant, which is Kb1, will be what? We tag this place as Kb1 and we have what? M2S. So if we want to make Kb1 subject to the formula, this is what we'll now do, okay? But let's follow it step by step. We know that when this one combine and form this M2S, it can still combine further, B. That's why we now have M2S combining with another S again to form what? M2S2. The first one was called Kb1, which is binding constant 1, while the second one is now called binding constant 2. Now, binding constant 1, which is Kb1 now, is equal to what? The product all over what? The reactant. The reactant. Okay? So, product all over the reactant. The next thing is that I will make this guy subject to the formula. So, M2S now will now be what? Kb1 times M2 and what? And S. This one is now our equation 1. The same thing I did here. The same thing I did here for Kb1, I will also do it for Kb2, and I believe you know what to do, right? So just follow the same process. Just the way we make Kb1 subject of the formula. In like manner, make Kb2 subject of the formula. Let's do it now. Let's do it now. So if I'm to make Kb2 subject of the formula, what will I do? Shall we take Kb2, right? Kb2 is equals to what? Kb2 is equals to what? It's equals to what? Product all over reactant. Product all over reactant. What's my product there? M2S2, right? Hope you can see. M2S2. So we have things like what? M2S2. Is it clear? M2S2 all over what? What's our reactant there? What's our reactant? Our reactant there is what now? M2S in bracket what? S. Right? Now you know what we did, right? We make once we get an expression for Kb2, what was the next thing we did? We quickly make this bound subject of the formula. So in like manner, making M2S2 subject of the formula, I'm not going to write that stuff, but just know that we make M2S subject of the formula, such that we will now have something like this. M2S2 is equals to what? Kb2, right? In bracket M2S, right? And then what? Then S. Now you'll be tempted to say this one should be equation 2, but please, there's something we can substitute. There's something we can what? We can substitute. Now look at this M2S here. We can substitute for M2S, right? We already have an expression for M2S. Look at equation 1. They said M2S is equals to what? Kb1, M2, and what? And S, right? So instead of me to write M2S, I will just write this to replace what? To replace what? To replace M2S. So I will now say therefore my M2S2 is equals to Kb2. I want to write M2S. Now what is M2S? What is M2S? This is M2S, right? So we'll now call it what? Kb1, then what? M2, then what? S, finish. Abi then this last S here. This KB1, M2 and S is this one. Then this S is still here, right? So instead of me to write the S, I will just put it as S square. So let me put this one in bracket also. You understand? So this one will now become our what? This one will become our what? Equation 2. Do you understand? So this is how you get at the equation. Let me just wrap it up again so that we can close this one up. Then we'll go move to the next thing. I get my point. All right. So listen now. This is for a dimeric protein. This is for a dimeric protein. This is for a dimeric protein. For a dimeric protein, we have what? M2, meaning two binding sites are available, combined with the substrate to form what? M2S. M2S again combined with another substrate to form what? M2S2. This one is binding constant 1, this one is binding constant 2. This region here, we call it what? This region that I put in bracket, they are the unbound region or bound protomer. Why this one is not called the what? The bound protomer. Are you getting my point? All right. Now listen. Now, what is my KB1? Product over reactant. My product there is what? M2S all over what? What is my reactant? M2 and what? S. Making M2S subject to the formula. What do we have? KB1 M2S equation 1. I get my point. Then the next thing now we'll now do is what? KB2. KB2 there is what? Product over what? Over the reactant. So making this bound protomer subject to the formula again, we'll now have what? KB2, M2S, then what? S. But we already know what M2S mean, right? From equation 1. So we'll quickly substitute it into this place. We'll now have something like what? M2S2 is equals to what? KB2, KB1, M2, then what? S squared. This one will be our equation 2. Now that we have expression for these two, for the bound protomer, once we have expression for the bound protomer, the next thing now is to introduce a concept called fractional saturation. Fractional saturation. So in the next video, we'll continue from here and wrap up for a dimeric protein by introducing the concept of fractional saturation. Fractional saturation, okay?